Alexa in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths E. We have started our discussion with the chapter Complex Numbers. What did we learn? We started what is complex numbers, what is its addition, multiplication and all those operations. Today we are going to learn how do we form equations of locus in this complex plane. Okay, and don't forget that complex plane is also called as organd plane, where the x axis is a real axis, whereas y axis is an imaginary axis. Clear? Fine. Look at this question here. He is telling that x plus iy equal to 1 by 1 plus cos theta plus I sin theta. Then show that 4x square minus 1 equal to 0. Okay. How do we do is, first we have to simplify this. X plus iy is equal to 1 by 1 plus cos theta is 2 cos square theta by 2. Sin theta is 2 sin theta by 2 cos theta by 2. Okay. What is the need of doing this bole to? We have to convert these two terms into single term. So 1 by, let us take 2 cos theta by 2 as common, I will get it as cos theta by 2 plus I sin theta by 2. Clear? Let us put it as it is, we will not disturb it and rationalize this. What do we get? What do we get? Cos theta by 2 minus I sin theta by 2 divided by cos theta by 2 minus I sin theta by 2. Okay. A plus ib into a minus ib, that will be a square plus b square, that is nothing but cos theta by 2 minus I sin theta by 2 divided by 2 cos theta by 2 into a square minus b square, that is cos square theta by 2. I square is minus 1, minus 2 minus plus sin square theta by 2. Cos square plus sin square is 1. Therefore, I will get it as cos theta by 2 minus I sin theta by 2 divided by 2 cos theta by 2. This is x plus iy. Clear? Now check, x plus iy is equal to cos theta by 2 by 2 cos theta by 2 minus I sin theta by 2 by 2 cos theta by 2. Fine. Here cos theta by 2 will get cancelled. I will get it as x plus iy as 1 by 2 minus I into sin by cos is tan theta by 2 whole divided by 2. So, let us equate only x term, that is let us equate only real part x is equal to half, then 2x is equal to 1. If I square on both sides, I will get it as 4x square is equal to 1, therefore 4x square minus 1 equal to 0. Clear? How do we know that? We have to take only real part, because he is asking us to show only in terms of x. So, we have to take only x. Clear? Then how do we know that we have to square on both sides? Because here it is 4x square, we should understand that this has to be squared. Clear? Shall we move on to the next question? Let us do. The next topic we are going to discuss is a polar form. What is this polar form? That is, whatever the form which we have seen till now, a plus ib, this is popularly called as rectangular form. Okay. So, we have to convert this rectangular form into polar form. How does it look? That is, z is equal to r into cos theta plus I sin theta. Okay. What is this r? What is this cos theta? What is this sin theta is? Here r is called as amplitude. Okay. Whereas this cos theta plus I sin theta, whatever the terms, the theta here it is called as argument. Okay. That is, r is magnitude, sorry, r is called as amplitude. Okay. And theta is called as argument. This is nothing but to convert z is equal to x plus iy into this form is x square plus y square, whereas argument is tan inverse y by x. Clear? Yes or no? then the magnitude of z is given by, again same, x square plus y square. This is called as magnitude. Okay. Based on this problems, we will convert this into rectangular to polar form, polar to rectangular form. Okay. And this particular term, whatever we see, it is popularly called as e power I theta or simply cis theta. Okay. We will completely discuss about this statement in our next chapter. Is it clear? Shall we do a few problems of this form? Let us do. Look at these questions here. He is asking us to express these particular complex numbers into mod amplitude form. Mod amplitude form is nothing but our popular polar form. Okay. See here, that is, it is written in the form of a plus ib. A is equal to 1, b is equal to root 3. Fine. So, we have to find theta as well as, what is it, one more, r. What is theta now? Theta is tan inverse y by x. When do we get root 3 in tan? That is nothing but r pi by 3. Okay. What about r? R is nothing but under root a square plus b square, that is root 4, that is 2. Therefore, in polar form, a into, what is it, cos theta plus I sin theta. This is the polar form. Anything difficult in this? No, right? This is what we got, right? This is z equal to. Clear? Now, let us find the same thing for next question. What is a? A is 1, b is minus 1. What is theta? Tan inverse minus 1 by 1, which is tan inverse minus 1. What is, I mean, when do we get 1 in for tan? That is pi by 4. Yes, we know it. When do we get minus pi minus 1? That is in the second quadrant, that is pi by 2 plus pi by 4. 90 plus 45, that is 135. That is nothing but tan inverse 3 pi by 4. Okay, that is nothing but 3 pi by 4, that is it. Okay. What about amplitude? Under root 1 plus 1, that is root 2. Therefore, my complex number root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. Done? Fine. Look at the next question here. If z1 is minus 1, z2 is I, find the argument of z1 by z2, it seems. How do we find? First we have to find z1 by z2. So, here z1 by z2 is equal to minus 1 by I. We will rationalize it. I will get it as minus I by I square, that is minus I by minus 1, that is equal to just I. Okay, we have to find argument of that. So, that can be written as 0 plus 1 I. What is A here? 0. What is B? 1. What is argument of that? That is argument of z1 by z2 is equal to tan inverse 1 by 0, that is tan inverse infinity, which is nothing but 90. Is it clear? Did you understand? We can also do it in different method, that is argument of z1 minus z2 can be written as argument of z1 minus argument of z2. Okay. From that formula also we can get the same answer. Okay. Since it is in the division form, we will get the minus. If it is in the product form, we will get plus. Okay. Shall we do next problem? Let us look at the next question here. Here he is telling pi by 5 and pi by 3 are arguments of z1 bar and z2. So, how do we find the argument of z1 and z2? Just tell me. The thing you have to remember is argument of z plus argument of z bar is always equal to 0. Clear? So, from this we can write the argument of z1 as directly minus pi by 5. So, let us find argument of z1 plus argument of z2 directly. What is argument of z1? Minus pi by 5. What is argument of z2? Pi by 3. Okay. The LCM is 15. We will get it as minus 3 pi plus 5 pi. I will get it as 2 pi by 15. Clear? Fine. Shall we go to the next problem? See here. He is telling that a plus ib whole square is equal to x plus iy. Whether they specify or not, whenever there is a square, it should be under a modulus term. So, let us apply mod on both sides. What do we get? We will directly get it as a plus ib mod is equal to x plus I mod. Okay. Is it clear? So, we can write it as what is a plus ib ka mod? That will be a square plus b square under root whole square is equal to, the modulus of this is x plus y square under root. Okay. So, this and this will get cancelled. I will get it as x square plus y square is equal to a square plus b square whole square. That is it. Clear? Is there any difficulty? Fine. Look at this next question. He is asking us to find the locus of mod z minus 3 plus I equal to 4. In order to find the locus, let us assume the z as x plus iy. Let z is equal to x plus iy. Let us substitute it and apply modulus. What do we get? Here modulus of x plus iy minus 3 plus I is equal to 4. So, let us take all like terms together. Here it will be x minus 3 plus y plus 1 into I is equal to 4. This is a real term and this is a imaginary term. What is modulus? Under root of real square plus imaginary part square. Then we get it as under root of x minus 3 whole square plus y plus 1 whole square equal to 4. Let us square on both sides. I will get it as x square plus 9 minus 6x, y square plus 1 plus 2y is equal to 16. Okay. So, we will keep all x square plus y square terms first, minus 6x plus 2y, 9 plus 1 is 10, 10 minus 16 is minus 6 equal to 0. This is a locus for a given equation under the modulus. Clear? Shall we move on to the next problem? Let us do. Look at the next question here. Find the locus of z equal to x plus iy if this particular term is completely imaginary and the real term of this is equal to 0. We will get two locus. So, let us simplify this and just equate real term to 0, whatever the thing which we get, that is nothing but our equation. Okay. See here, let us substitute z equal to x plus iy. What do we get? X plus iy minus I by x plus iy minus 1. We get it as x plus I into y minus 1 divided by x minus y plus iy. Okay. Now, let us rationalize. So, we will get it as x minus 1 minus iy divided by x minus 1 minus iy. Okay. Let us multiply all these terms individually. So, I will get it as x into x minus 1 minus iy plus I y minus 1 into x minus 1 minus iy divided by x minus 1 into x minus 1, that is x minus 1 whole square plus y square. Okay. Now, let us take all imaginary terms to one side. Let us multiply this x square minus x minus I into xy plus, let me write it as iy minus I. Okay. So, that we can simplify it easily. That will be I x y minus I y minus to minus plus I square y square. Then next let us multiply I minus x I minus I minus to minus plus I, and here again plus I square y whole divided by x minus 1 whole square plus y square. Clear? So, let us bring all singular terms to one side, x square. Next, where is y square? Here it is y square, that is nothing but minus y square, and next minus x. Next, till what are the terms? here also it is minus y divided by x minus 1 whole square plus y square. Next minus I into, let us take is isy, ixy will get cancelled. So, let us take minus I common, I will get it as y plus x plus 1 divided by x minus 1 whole square plus y square. Clear? He is telling that this particular complex number is purely imaginary. What does this mean? It clearly tells that the real part is equal to 0. Okay? That means this part should be equal to 0. If we equate it to 0, I will get the locus as x square minus y square minus x minus 1 equal to 0. Is it clear? Fine. Look into this next question. Here also the same format. He is telling real part is equal to 0. So, we can directly substitute and simplify. What is z? Z equal to x plus iy minus 4 by x plus iy minus 2y is equal to 0, that is x minus 4 plus iy divided by x plus y minus 2 into I equal to 0. Let us rationalize it. What do we get? We get x minus y minus 2I by x minus y minus 2 into I is equal to 0. Let us multiply each and every term. What do we get? X into x is x square and here it is xyi. Okay. Let me write this term directly. We will get it as yi plus 2i. Now, we can directly write, right? X into x is x square, xyi, and the next x2 is 2xi. Clear? Now, let us multiply with the 4. 4x minus 4yi minus 4 2 is 8i plus xy into I minus y square I square plus 2y I square divided by x square plus y minus 2 whole square. Clear? Check whether any number will cancel, xyi will get cancelled, and the next x square is equal to 0, x square, and the next here it is y square plus y square, next x term minus 4x, and the next y term minus 2y divided by x square plus y minus 2 whole square. However, this is the real term, this is equal to 0, therefore, the locus is x square plus y square minus 4x minus 2y is equal to 0. Is it clear? Shall we go to the next problem? Let's do. Look at this question. Show that in the argand plane, these 4 points are 4 different coordinates in a rectangular coordinate system. Taken in order form a rhombus. When we can say 4 points form a rhombus, that is all 4 sides should be equal and the diagonal should be equal. Okay. So, let us write them in the form of coordinates minus 2 comma 7, minus 3 by 2 comma 1 by 2, 4 comma minus 3, and finally 7 by 2 comma 7 by 2. Clear? These are the 4 points. Let us find all the distances AB, BC, AC and AD. AB is under root, let us say this as A, B, C and D. Let us find AB, minus 3 by 2 plus 2 whole square plus 1 by 2 minus 7 whole square, that is nothing but 2 2s are 4. Okay, 4 minus 3 is 1, that will be 1 by 4 plus here it is 7 2s are 14, this is 169 by 4, therefore, it will be 167 under root by 2. Similarly, let us find BC. What do we get? 4 plus 3 by 2, okay, and minus 3 minus 1 by 2 whole square. We get it as 4 2s are 8, 8 plus 3 is 11 by 2 whole square plus here minus 6 minus 1, that is minus 7 by 2 whole square. We will get it as 121 plus 49. How much it will be? Whole divided by 4. We will get it as 160 by under root 160 by 2. Clear? So, let us find CD. let us find CD. This will be 7 by 2 minus 4 whole square plus 7 by 2 plus 3 whole square. What do we get? 4 2s are 8, 7 minus 8 is minus 1 by 2 whole square plus 7 plus 6, that is 14 by 2 whole square. Clear? 7 plus 6, that will be 13. Clear? This will be 1 by 4 plus 169 by 4. Again I will get it as 170 by 2. Okay, here also it is 170 and here also it is 169 plus 1, that is also 170. Fine. The next AD. AD 7 by 2 plus 2 whole square plus 7 by 2 minus 7 whole square. What do we get? 7 by 2 plus 4, that is 7 plus 4. 7 plus 4 is 13 by 2 whole square plus again 7 minus 9, that is minus 2 by 2 whole square. Clear? 7 minus 7 2s are 14. Obviously it is also 7. Clear? What is 13? 13 ka square is 169 by 4. Again here it is 49 by 4. How much do we get? 7 plus 4 is 11. Therefore this is 121. 121 plus 49 again 170 by 2. All sides are equal. Therefore we can tell that the given points A, B, C, D form a rhombus in argand plane. Clear? Fine. What all problems we did in this chapter? We started with the basics of complex number, then we did a few problems of how do we add two complex numbers, then the polar form. Clear? Fine. By this question we can end the chapter, that is complex numbers. Hope everything is clear for you. Let us meet in the next session with the new chapter of 2A. Thank you.